afternoon, everyone. Okay, today we will be looking at coordinate systems in GIS. Now, what is a coordinate system? This is a framework of reference lines axis used to uniquely define the location of points in space. Okay, the most common known are the X and Y axis for distance, a geographic system using latitude and longitude on Earth. Okay, let me open my Q GIS. As it loads, I'll be explaining to you more about the coordinate systems in GIS, all the how we identify different places in geography or in GIS, and how we can assign the correct coordinates to a point in a map, so that we can georeference it or give it its actual coordinates based on the coordinates provided on the map. Now I will explain using two slides. Like, our globe has 4 quadrants: the first quadrant, the second quadrant, third quadrant, and the fourth quadrant. Now these quadrants are basically the same as used in mathematics, whereby we have the x-axis and the y-axis, whereby x-axis, this varies from this side is positive in the x-axis, this side is negative in the x-axis. Okay, this side is positive in the y-axis, this side is negative in the y-axis. So any point on the Earth's surface, the first quadrant will have positive x coordinate and positive y coordinates. Any point on the Earth's surface in the second quadrant will have negative x and positive y. Third quadrant will have negative x, negative y. Fourth quadrant will have positive x and negative y. Okay, now let's see how they are named. Okay, I will go to Chrome, whereby I'll just open the coordinate system, longitude and latitudes, and I'll come here and I'll explain how they are. So latitude and longitude are Earth's geographic coordinates, where longitude acts as the x coordinates. Note here, longitudes are the x coordinates, east west, ranging from negative 180 to positive 180. Okay, latitudes act as the y coordinates, north south, from negative 90 to positive 90, with equator 0 latitude and prime meridian 0 longitude as origins. Though on flat maps, these spherical coordinates are projected onto a flat x and y plane. Okay, from here I will explain more in the next video about the projections. Why we have x and y planes, like projected and geographic projections. Okay, now hope you have understood here. Longitude acts as the x coordinates, and it runs from east to west, ranging from negative 180 to positive 180, and latitudes acts as the y coordinates, north south, from negative 90 to positive 90. Okay, now let me open this here. Now I want to show you how we get this. As I said, longitudes are the x coordinates, longitudes, and the latitudes are the y coordinates. Basically, because, like, if we have, this is our longitude 1, longitude 2, this is longitude 0 degrees. Okay, this is prime meridian. This is longitude 15 degrees east, 30 degrees west. This is latitude 0 degrees, that is the equator. Sorry. So this is latitude 15 degrees north. Okay, so now that's how we identify points. For example, a point in, okay, this is the map of the world, right? Okay, let's assume we have our Cairo here, Cairo in Egypt. Okay, its coordinates will be 30 degrees north and 31 degrees east. 30 degrees north and 31 degrees east. That is for Cairo. Then we come here, let's say we have a city like New York. Obvious, it will be, this will be negative x and positive y. So it will be like negative 42 degrees. So it's x negative 42 and y 75 degrees north. Okay, then we come here like a city like Rio de Janeiro in Brazil. Both will be negative. For example, negative 22 degrees south and negative 43 degrees west of Prime Meridian. Now we come here to a city like Sydney is in Australia, which will be negative 33 south and 151 degrees east. Negative south and positive east. Okay, now that is basically what you need to understand for the coordinate systems. Okay, now if for example you are given a map or an image which you have to georeference and give it actual coordinates in QGIS, how will you identify if it's in the first quadrant, second quadrant, third quadrant, or the fourth quadrant? Let me show you. Okay, move with me into my QGIS. Then I will add a layer. I will add a last layer. Okay, I will come here and I will add one topo sheet which is from a part of Kenya, border between Kenya and Uganda. Okay, I will add Budadiri, then I will open it and add it. I will close it. Now, if you look at our topo sheet here, if I zoom in here, you will see that my map is 1 degree 10 minutes north. Okay, now that is north of equator. Okay, now that map is north of equator. That's how you know your map has been located. That is north of equator, because we said the equator identifies point from north or south. Okay, now let me try and see if I will see where, if it has been named as east. Okay, now we come here. Now we have identified it is north of equator. Then we have identified it is 34 degrees 25 minutes east of Greenwich. That is Prime Meridian. Basically, that tells us that our map is in the first quadrant, meaning all the points, that is x and y coordinates, are positive. Okay, now that is how we identify. After we have identified where our map is, now I will show you how to georeference the map and give it its actual coordinate, that if we load it in a base map, it will appear. Okay, now let me load just one base map so that you can OSM start that. You see, now this is my base map. You see, my map is located somewhere, like somewhere random. It has been randomly located. So I want this Budadiri map to appear in its actual location on the Earth's surface. That is, give it its actual coordinates. Okay, now move with me as I georeference this map. I'll go to layer, georeferencer, and I'll add my map Budadiri, and I'll open it. Okay, now this is my map, Budadiri. I will come here. Okay, there is some basics mathematics which you must know so that you convert this into degrees. I will add my point. Okay, I'll come here and I'll add my point. Now, okay, x is, we said our longitudes are our x and our latitudes are our y. So this is our x coordinate. So x coordinate will be 34 degrees 15 minutes. Now, how do you convert minutes into degrees? Simply, you just say 34 plus 15 over 34 plus brackets 15 divide 60, or 15 over 60, close the bracket. So it will be something like 34 plus 0.25, and that is our coordinate, which would be 34.25. If you add 34 plus 0.25, it is 34.25. Now our y coordinates, or not, our y coordinates will be 1.60, 15 divide 60, 0.25. So it's 1 plus 0.25, which is 1.25, that way. And we'll say, okay, our point has been input. Now we'll come here, you see. Now we'll come here and just add our point here, and this will be 34.30 over 60, 0.5. So 34 plus 0.5, so that comes to 34.05, 34.50, not 05, 34.50, that way. And this will be 1.25. Okay, I'll just say okay. Now I'll navigate to the bottom part of my map here, and I'll select this point here. Now that 4.50 and 1.0000, that way. Okay, I'll say okay, and I'll come to my point here. Hereby it will be 34.25, and this will be 1.00. Sorry, did it click here? 1.00, that one. I'll see. Okay, now I think you are wondering why I am selecting these points here. So basically, let me come here on top to this point on top. Okay, basically on how we used to read places in our topographic sheets, this is how we read places. We start with like these things and nothings. Like, for example, if you want to identify a point here, it's 40 degrees 40 degrees east, that's 7 degrees north or south. So here, this is the point. So now these are the coordinates of this point: 34 degrees 15 minutes east of Prime Meridian and 1 degree 15 minutes north of the equator. Okay, that's why I have, like, the coordinates are always provided here in a topographic map in Kenya. Topographical sheets of Kenya provide the coordinates towards the end. Okay, now after we have done that, I'll come to file, I'll save my ground control points. Those are the ground control points. Okay, see this as Kimilili, Budadiri, B, C, E. Okay, then I save my work. Then I run Georeferencing. Okay, I forgot to. Okay, to select output file, you just click there and say, okay, my output file is and this Budadiri modified. Although I can change, but I don't want to change. Then I'll run georeferencing layer. Yeah, the layer was successfully georeferenced. So I'll close georeferencer, that way, and I will have my modified here. Now, if I close this and I'll zoom this to layer, you see where my map is now. Now, my map is Mount Elgon National Park. You see, yeah, this is my map now. Yeah, the map was from a part of from the border of Kenya and Uganda. Yeah, I think this is Kenya. It covers most part of Kenya. Yeah, Uganda, most part of Uganda. It's a map of, now this is the boundary of Kenya and Uganda. You can see now the map is covering a part of, mostly part of Uganda and a small part of Kenya. So that's how we georeference and understand the coordinate systems of the earth. Okay, yeah, now those are the coordinates on a plane surface. Okay, plane surface. Now the next video I'll be looking at map projections, now between geographic and projected. Yeah, thanks for watching. Subscribe and stay tuned.